The Kobuk River is a river located in the Arctic region of northwestern Alaska in the United States. It is approximately 280 miles long, draining a basin with an area of 12,300 square miles. The Kobuk River is among the largest rivers in northwest Alaska, with widths of up to 1,500 feet and flow at a speed of 3–5 miles per hour in its lower and middle reaches. The average elevation for the Kobuk River Basin is 1,300 feet above sea level, ranging from near sea level to 11,400 feet. Topography includes low, rolling mountains, plains and lowlands, moderately high rugged mountainous land, and some gently sloped plateaus and highlands. The river contains an exceptional population of sheepfish, a large predatory whitefish within the salmon family, found throughout the Arctic that spawns in the river's upper reaches during the autumn. A portion of the vast western Arctic caribou herd utilize the Kobuk River Valley as winter range. Course. It is commonly assumed that the Kobuk River issues from Walker Lake. However, the headwaters of the river are to the east of Walker Lake in the Endicott Mountains within the gates of the Arctic National Park and Preserve, just north of the Arctic Circle. It flows briefly south, descending from the mountains through two spectacular canyons, then flows generally west along the southern flank of the Western Brooks Range in a broad wetlands valley. In the valley it passes a connected community of inland native villages, including Kobuk, Shungnak, and Ambler, where it receives the Ambler River. In the river's lower reaches, where it passes between the Bed and Waring Mountains, it traverses Kobuk Valley National Park, the location of the 25 square miles Kobuk Sand Dunes. It then passes Kiana. The river enters its broad delta approximately 10 miles southwest of Kiana. The delta is located in the Hutham Inlet of the Kotzebue Sound approximately 30 miles southeast of Kotzebue. History. The Kobuk Inuit name means Big River. It was first transcribed by John Simpson in 1850 as Kawuk. Explored by L.T. G.M. Stoney, U.S.N. in 1883 to 1886, who wrote the name Kobuk, proposed that it be called Putnam in honor of Master Charles Putnam, U.S.N., officer of the Rogers, who was carried to sea on the ice and lost in 1880. L.T. J.C. Cantwell, USRCS, also explored the river in 1884 and 1885 and spelled the name Kuvak on his map and Kovac in his text. Ivan Petrov spelled the river name Kawak in 1880, and W. H. Dahl spelled it Kauk in 1870. L.T.H.T. Allen, USA, obtained the Koyukon Indian name in 1885, which he spelled Holorotna and Holotna. Native peoples have hunted, fished, and lived along the Kobuk for at least 12,500 years, and it has long been an important transportation route for inland peoples. In 1898, the river was the scene of a brief gold rush called the Kobuk River Stampede, which involved about 2,000 prospectors in total. Clearing of gold along the Kobuk and its tributaries. Miners set out from Seattle and San Francisco on ships to reach the mouth of the Kobuk. Upon arrival they were informed by native people that it was a scam, and only about 800 traveled upriver. The result was that little or no gold was found, and only on a few tributaries of the river. In 1980 the United States Congress designated 110 miles of the river downstream from Walker Lake as the Kobuk Wild and Scenic River as part of the National Wild and Scenic Rivers System. The river is considered an outstanding destination for recreational floating. Climate. The Kobuk River Basin is located just north of the Arctic Circle and has a continental climate. The summers are short and warm, while winters are long and cold. The mean annual temperature in the middle and upper portions of the Kobuk Valley is -6°C, and the mean temperature in July is 15°C. An average of 21 inches of precipitation falls in the basin. However, actual precipitation can range from 15 to 40 inches, with greater amounts falling in the upper reaches of the river basin. The Kobuk River Basin is very sensitive to changes in climate. Arctic climates have warmed at approximately twice the global rate in the last several decades. Records of air temperature from 1961 to 1990 logged at the latitudes of the Kobuk River show a warming trend of about 1.4 degrees Fahrenheit per decade. The warming has been the strongest in the winter and spring months. Climate change is presently considered the most severe environmental stress in the Kobuk River Basin and throughout Alaska. As a specific example, climate change will cause widespread thawing of permafrost in the discontinuous zone and significant changes in the continuous zone. Thawing permafrost can lead to a landscape of irregular depressions due to subsiding soils. This can alter drainage patterns and even change the course of streams, whereas other areas could become swamp-like. In addition, slope stability will decrease and permafrost degradation could lead to erosion of riverbanks, resulting in an increase in sediment transport by the rivers. These physical changes will impact nutrient cycling and biological processes within the basin as well. Geology and soils. Permafrost regions along the Kobuk River are shown in the accompanying figure. Geomorphology. The Kobuk River is a periglacial river, fed by a remnant glacial lake and mountain snow melt in the Brooks Range. It cuts a channel through a landscape otherwise dominated by permafrost. The Kobuk's current form and structure is a direct result of several stages of erosion and channel formation following the last glacial retreat. As the glacier first retreated and melted, large amounts of highly erodible, fine-grained sediment dropped out in relatively high mountain valleys. The availability of this fine-grained, loose sediment combined with a high gradient to turn a newly forming Kobuk River into a fast-working sediment transport system. The river picked up glacial till from its upper reaches and transported it downstream until the gradient diminished. When the river encountered flatter ground, it deposited its sediment load, resulting in the creation of broad, flat floodplains, alluvial fans, and meander bends through a gradation. After the first stage of gradation and sediment transport, the Kobuk began a new phase of erosion and landform development. The river exhausted its supply of easily erodible sediment upstream, thus decreasing its sediment load and increasing its load-carrying capacity downstream. With more capacity downstream, the river began to incise into the alluvial fan it previously created, moving sediment stored for a long time on its original floodplains to newer floodplains even further downstream. Further down in the Kobuk watershed, the river worked in concert with the wind to create one of the more famous landforms in Alaska, the Kobuk Dunes. These large sand dunes are the modern ancestor of alluvial deposits that became shaped and dominated by an exchange of aeolian and fluvial processes. In moister climates, the river has more water, and thus more power, and cuts down through a sandy bed. In times of dry climate, wind dominates and blows a lot of sediment into a weaker fluvial system, leading to a gradation and floodplain redistribution. Currently, the Kobuk River in its middle and lower reaches is an anastomizing stream, with several braided channels in places, wide migrating meander bends, and oxbow lakes. It is controlled by yearly cycles of freeze and thaw, much like its surrounding landscape. For 6 months of the year, the river is largely still, frozen on top by a thick layer of ice. In the spring, warmer temperatures cause this ice to begin to melt. But the resulting process is not gradual. Rather, the pressure of melting ice from upstream builds up upon ice dams in the river's channel, eventually causing an ice breakup event, in which a flood of ice and water moves powerfully downstream. These annual spring breakup events have several important consequences. First, the river has deeply undercut and eroded banks, caused by large, fast-moving chunks of ice carving out the river's channel before it begins spilling out onto its floodplain, which is 1 to 6 miles wide except at the confluence of major tributaries. Second, the river moves laterally very quickly and dramatically, reinventing side channels every year as its secondary streams become drowned in each yearly flood by an overwhelming amount of sediment. Lastly, since the river is surrounded mostly by permafrost and because during the spring breakup event there are still large parts of frozen ground close to its banks, floods often transports large amounts of fine sediment across broad expanses of floodplain in thin sheets of water that slide easily across the frozen ground. These characteristics also translate into a relatively variable habitat for the Kobuk's native species. Farthest west, the Kobuk empties into Houtham Inlet, the easterly arm of Kotzebue Sound. During recent geologic times, however, when sea level was lower, the Nawatik, Kobuk, and Selawik rivers were joined. Now, they have separate deltas with many lakes and swamps and intricately webbed channel systems. The deltas are composed primarily of silt, sand, and gravel, surface water and hydrology. The Kobuk River is ice-covered 6 months of the year and in general, late October to late May is a period of relatively low flow. Annually, the hydrograph reflects 2 flood peaks. The first is associated with spring breakup and the second, a lesser peak, is associated with late summer precipitation. As the snowpack begins to melt toward the end of May, flow in the Kobuk River increases with most of the runoff occurring during June. Flow during the summer is dominated by variable precipitation events. Most of the major tributaries of the Kobuk River flow from the north, draining the mountains in the southern Brooks Range. From east to west, these include the Reed River, Beaver Creek, Mornaluk River, Kogluktuk River, Chungnak River, Ambler River, Akinik River, Tutuksuk River, Salmon River, and the Squirrel River. Within Kobuk Valley National Park are the Kalarichuk, Kalagurakiak, and Adilik rivers. All of the headwaters are in the Baird Mountains. The major tributaries flowing north from the Waring Mountains of the Par River, Pick River, and Yaktuvik Creek. The Par River drains a lowland area of the basin. Most major tributaries draining high-relief areas have higher unit runoff than tributaries draining the lower relief areas. Walker Lake is at an altitude of 194 meters in the headwaters of the Kobuk River. Other surface water features within the basin include Lake Selby, Nutavukti Lake, and Norutak Lake. Additionally, numerous small lakes and ponds occur in the lowlands along the river, some formed as detached oxbows of the meandering river and others formed where permafrost has melted and caused depressions. Flow records are available from USGS monitoring stations at Ambler and Kiana. Average annual flow for the Kobuk River at Ambler has ranged from 5,839 cubic feet per second to 14,890 cubic feet per second over the period of record 1966 to 78, with peak discharge ranging from 30,000 cubic feet per second to 95,000 cubic feet per second. Near Kiana, average annual flow has ranged from 10,020 cubic feet per second to 24,960 cubic feet per second for the period 1977 to 99, with peaks of 45,000 cubic feet per second to 161,000 cubic feet per second. Peak flows can result from large volumes of water released when ice jams fail. Flow records are also available for Dull Creek, a tributary of the Kobuk River with a confluence near the town of Kobuk.